Hello everybody, this is review number 2 for constant velocity in our week 11 Classkick. So we're going to go ahead and review what our slope and mathematical models are on this graph. This graph has 4 segments. There's 1 and 2. Oh, let me write in the point for 7.5 and 10. So this is segment number 1 right here with 0, 40 to 7.5, 10. Segment number 2 is this upward slope one. Segment number 3 is this flat one, and number 4 is this one going all the way down to 0. But let me change the color so you can see the difference. All right, so now we see 4 very distinct, very different segments in this one object's motion. We're going to calculate the slope, show our work, and we're going to write the mathematical models for some of the segments, but not all. And so the equation for a mathematical model is xf is equal to vt plus xi. And so to calculate our velocity, we're going to calculate the slope of our first segment. So we're going to find the difference between the 2 points, 0, 40, and 7.510. So the final position is 10 meters minus initial position of 40 meters over 7.5 seconds minus 0 seconds. We're going to go 10 minus 40 is negative 30 meters over 7.5 minus 0 is going to be 7.5 seconds. And then what you're going to do is divide it into your calculator and make sure your answer shows up as a decimal point. And so when you go negative 30 divided by 7.5, you should get 4 meters per second. But it is a negative. Let me erase it and make it more clear that it's negative 4 meters per second. So this is the velocity for segment 1. And now we're going to write the math model, which is the equation. So we have the velocity, but we just need so velocity is negative 4 meters per second times time plus the initial position of wherever it started at time 0, which is going to be 40 meters. And so this is our mathematical model for part 1. And that is where the initial position is. All right, now for part 2, we see that it is no longer at a negative direction. Now it's increasing in position. So we're going to take a look at our points. Final position is 60 meters minus initial position of 10 meters for final time at 12.5 seconds. So let's write it down here. 12.5 seconds, and then the initial time of 7.5. So we're going to write the time for when it started. So 60 minus 10 is going to give us 50 meters over 12.5 seconds minus 7.5 is going to give us 5 seconds. All right, so now we have 50 meters divided by 5 seconds is going to give us 10 meters per second. And that is our velocity. We're not going to write the mathematical model for this because it's a little bit more complicated than what I taught you in class. So that's going to be fine. Now, but what we can do is write the displacement. And the displacement is just the final position minus initial position for this segment. So the displacement is going to be 60 meters minus 10 meters. Which is going to give us 50 meters. And so the displacement was 50 meters from wherever they started at 10 meters and ended at 60. Okay, now we're going to calculate, the mathematical model, if you're interested, is 10 meters per second times time, and then the y-intercept. Your algebra teacher taught you how to do this. I didn't teach you how to do it, so I'm just going to leave it blank. All right, now the slope for the third segment, we're going to see that it is flat. That means that it is a slope of 0, right? Doesn't mean there's no slope. It just means that the slope is 0. So 60 meters minus 60 meters, because it didn't go anywhere. Its initial and final is the same. Over 18 seconds minus 12.5 seconds. And we're going to get 60 minus 60 is going to be 0 meters over 18 minus 12.5 is going to be, let's see. I'm sure we could do this in our head, but I don't know why I'm writing 3. It's not 3. It is 5.5. So let me erase this and write 5.5 seconds. All right, so 0 divided by 5.5 is just going to be 0. And so we have a velocity of 0. That means that the object was stopped and not moving. Now the mathematical model for this is going to be fairly easy. Final position is equal to the velocity of 0 meters per second times time plus 60 meters of where it was the whole time. Now there is no slope, so here we go. So the final position is going to be at 60 meters. All right, next the slope for part 4. And it's going to be same thing, calculate the velocity, and we have 0 meters, it's its final position, and 60 meters is the initial position for when it started for this segment. 24 seconds minus 18 seconds is going to give us negative 60 meters over 6 seconds is going to be negative 10 meters per second. And like number 2, we're not going to write down the mathematical model, but we'll write down the displacement for part 4. And we're just going to look at where it started and where it ended. So it ended minus where it started, and it ended at 0 meters minus 60 meters is going to give us negative 60 meters. All right, so now we're going to look at this next part. Given the position graph at the left or above, describe the motion of the object in words. And so we'll break it up into 4 parts. The first part is the object started at 40 meters and traveled 4 meters per second in the negative direction for 7.5 seconds. And make sure that we talk about the direction. So it moved in the negative direction for 7.5 seconds. And we see it with the slope going down towards 0. Now the second segment is we see a different direction. So then it moved for 5 seconds. So 7.5 to 12.5 is 5 seconds. So it moved for 5 seconds in the positive direction because we see the slope changing direction. It's moving up. The position is increasing, so therefore it's a positive direction at a speed of 10 meters per second. All right, next we have the third segment, and the object remained at 60 meters for 5.5 seconds. So we'll just say that it remained at 60 meters for 5.5 seconds. And part 4, we see the direction of it changing once more, and it's going in a negative direction. So for part 4, when it started moving again, it started moving towards 0 meters. So when it started moving towards 0 meters for 6 seconds, so 0 meters for 6 seconds. With a speed of 10 meters per second in the negative direction. So for 6 seconds with a speed of 10 meters per second in the negative direction. And next, we're going to calculate the total displacement of everything. So total displacement from the very, very beginning all the way to the very, very end. So we're going to look at where the object started at time 0 and where it ended at time 24, since that's how long the object traveled for in our graph. So it's going to be 0 meters minus 40 meters, that's where it started, and it's going to give us a displacement of -40. And that's it.